The next part of second module is permeability of soil. Okay, the property of soil which permit the flow of water through it. Okay, in other words, it is an engineering property of soil which permits the flow of water through the voids present in the soil. Okay, a soil is a pervious or permeable if water can flow through it. Okay, hydraulic gradient. Okay, the loss of head per unit length of flow. The loss of head per unit length of flow through the soil is called hydraulic gradient. Okay, it is given by I equal to H by L, small h by L. So you might get questions for 5 marks. I think if for 5 marks there might be three uh, parts like A, B, C. So there might be a question like define hydraulic gradient. So you can expect this kind of question. So H is hydraulic head divided by length of soil measurement. Next comes the Darcy's law. The flow of free water through soil is governed by Darcy's law. So, Darcy's law states that the velocity of flow through soil is proportional to hydraulic gradient. That is, V is directly proportional to I, which can be given as V is equal to Ki. K means coefficient of permeability in centimeter per second. Okay, V is the velocity of flow in centimeter per second. So it is also called discharge velocity. So the discharge of flow Q is given by A into V. Right. Your discharge is given by A into V, which you have studied in FM. Right. So Q is equal to Ki into A. A is the cross sectional area of sun. I hope you have studied Reynolds number from FM, right? If hydraulic gradient is unity, the coefficient of permeability is equal to velocity of flow. Okay, so I is 1, then permeability is equal to velocity of flow. Okay, so Darcy's law is valid if the flow through the soil is laminar. Flow through the soil is laminar if Reynolds number is Ra is less than or equal to 1. So there are some points regarding validity of Darcy's law, and then determination of coefficient of permeability. So determination of coefficient of permeability, there are two types. Two lab procedure, that is constant head permeability test and variable head permeability test. Okay, you can just go through it. Okay, and there are equations for it. So there might be questions regarding there must be problems regarding this portion. Okay, most probably. So procedures are not much asked. Okay, so you can just go through it as it's a theory portion. And one of the important topic which comes under permeability, the factors affecting uh, permeability of soil. Okay, so there are several factors: viscosity of water, void ratio, particle size. Okay, there are explanation of all these things. Okay, you can go through it. Okay, which is very important. So this question might be asked for 6 marks. Okay. Permeability of stratified soil deposit. A stratified soil deposit consists of a number of soil layers, okay, having different permeability. So the stratified soil is something which has a number of soil layers, and they will be having different permeability. The average permeability of the deposit is a whole parallel to the planes of stratification, and that normal to the plane of stratification can be determined as explained here. So flow parallel to planes of stratification. Okay, so we take here loss of head H over a length L, H over a length L, same for all layers. Okay, so it is same for all layers. Okay, therefore the hydraulic gradient for each layer is equal to hydraulic gradient of the entire deposit. Okay, so total discharge equal to sum of discharge in individual layer Q1, Q2, Q3. So it is given by KH. Okay, for parallel, KH is equal to K1H1 plus K2H2 plus K3H3 divided by H1 plus H2 plus H3. So KH is average permeability of soil deposit with parallel flow, okay, or along horizontal direction. So K1, K2, K3 is permeability corresponding to first layer with thickness H1, second layer H2, third layer. Okay. Next comes flow normal to the plane of stratification. So discharge is the same in all layers. Okay, discharge is same in all layers. Total head is equal to sum of head in all individual layers. So it is H is equal to H1 plus H2 plus H3, whereas in parallel it is Q is equal to Q1 plus Q2 plus Q3. Okay, it is given by Kv is equal to H1 plus H2 plus H3 divided by H1 by K1 divided by H2 by K2 plus H3 by K3. So K1 is the average permeability of soil deposit perpendicular to the flow or along vertical direction. Okay, here KH is always greater than KV. Okay, so we have a problem here. Determine the average coefficient of permeability in the horizontal and vertical direction for a deposit consists of three layers of thickness 5 meter, 1 meter and 2.5 meter and having coefficient of permeability of 3 into 10 power minus 2 mm per second. Okay. For corresponding all layers are given the values, that is coefficient of permeability. So the question is very direct, right? It is asked to find the horizontal and vertical direction. Okay, so we have KH horizontal K1H1 plus K2H2 plus K3H3 divided by H1 plus H2 plus H3. So 3 into 10 power minus 2 multiplied by, so as it is given in meter, we convert it to mm, right? 5 into 10 power 3 and substitute for everything K2H2 and K3H3 divided by H1 plus H2 plus H3. You get KH equal to 0.0294 mm per second. Whereas for vertical, we know the equation, and that is H1 plus H2 plus H3 divided by K1 by H1 by K1 plus H2 by K2, H3 by K3. Okay, you substitute a value and you get here again. Alright. And there is a simple problem for constant head permeability test. Okay, the directly equation K is equal to QL by AH. And we have one more problem. Okay, the falling head permeability test was conducted on a soil mass of 4 centimeter dia and 18 centimeter length. Okay, the head fell from 1 meter to 0.4 meter in 20 minutes. If the cross-sectional area of the standpipe was 1 centimeter square, determine the coefficient of permeability. Okay, it is given it is falling head permeability test. So for falling head permeability test, we have K is equal to 2.303 AL divided by 80 multiplied by log to the base 10 H1 by H2. So it is given, area is given, right, 1 centimeter square. A is substituted. And what is the length given? Length is given as 18. Right, 18 centimeter is given. Okay, so even the area is in centimeter. Okay, divided by area. Well, what will be the area? Pi by 4 into 4 square. Right, 4 meter. Right, sorry, it is 4.4 meter. So we take it as 4 square multiplied by 20 into how many minutes it is? Time. 20 into, as we have to convert it to seconds, we take it as 60. Multiplied by log to the base 10. What is the first head it was given? It is given as 1 meter. Right? Divided by 0.4 meter. Right. Sorry, I've mistakenly said it is converted to 0.4 meter. It is already given 4 centimeter there. That is pi d square by 4 equation. Okay. So you get the answer. K is equal to 1.093 into 10 power minus 3 mm per second. Do remember to write the unit of whatever answer you get. Okay. Do not forget. I've seen lot of wrong answers as no unit, etc. So this is very simple problem. You can just refer Aurora and Punmia textbook for much more better problems. Okay.